Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Synthetic Data Generation. When real data is scarce. Create your own. Imagine you want to teach a computer to recognize cats in pictures. How would you do it? You'd show it tons of pictures of cats. And not cats. Until it learns the patterns. This teaching material is called asterisk data. For AI, data is like food for a growing child. It needs a lot to learn and get smart. But what if you don't have enough data? Or the data you have is secret? Or biased? That's a huge problem for building useful AI. This is where creating your own data comes in. Think of synthetic as man-made or artificially created. So, synthetic data is simply data that isn't collected from the real world, but is generated artificially by a computer program. It's designed to look, feel, and behave just like real data. Like a master baker who can create a perfect imitation cake using their own ingredients. Computers can create data that mimics the properties of real data without ever seeing the real thing directly. As a developer, you'll often face these situations where synthetic data is a lifesaver. 1. Scarcity. Asterisk you want to build AI for a rare disease, but there are only a few patient records. 2. Privacy. Asterisk you have sensitive customer information, but you can't use it directly for training due to privacy laws. Synthetic data can mimic it without revealing real details. 3. Bias. Asterisk real-world data can have unfair biases, e.g., facial recognition models struggling with certain demographics. Synthetic data can be designed to be more balanced. 4. Cost and time. Asterisk collecting massive amounts of real-world data, like for self-driving cars, is incredibly expensive and time-consuming. 5. Specific scenarios. Asterisk you need data for dangerous or hard to recreate situations, e.g., car crashes, rare industrial failures. Synthetic data lets you simulate these safely. There are two main approaches a developer might use to generate synthetic data. 1. Rules-based generation. Asterisk you define specific rules or patterns. For example, if you need synthetic names, you might tell the program to combine a list of first names with a list of last names. It's like writing a script with clear, explicit instructions. 2. Machine learning-based generation. This is more advanced. Here, you show an AI some real data, if you have any, and it learns the underlying patterns, relationships, and distributions. Then, it uses that understanding to create completely new, similar-looking data points. Think of it like an artist who studies many real faces and then draws a completely new, believable face from scratch. Rules-based generation. Developer perspective. Asterisk you write code with if-else statements, loops, and functions to explicitly define how data should be created. Great for simple data types like addresses or basic text fields. Pros. Asterisk easy to control, predictable. Cons. Asterisk can't capture complex relationships. Data might look too perfect or unnatural. ML-based generation, e.g., using advanced AI models like GANs. Developer perspective. Asterisk you use specialized AI models, often available as libraries, that learn from existing data. You feed it real data, and it figures out how to make more. This is powerful for images, complex text, or data with subtle interactions. Pros. Asterisk creates highly realistic data, captures complex patterns. Cons. Asterisk requires more computational power, harder to debug if the generated data is poor quality, usually needs some real data to learn from initially. Where is this actually used by developers? Self-driving cars. Asterisk generating countless simulated driving scenarios, different weather, traffic, Obstacles. To train AI safely, without needing millions of real-world miles. Healthcare. Creating artificial patient records to develop new diagnostic AI models without compromising real patient privacy. E-commerce. Simulating user behavior or generating realistic product images to test new website features or recommendation engines. Software testing. Creating vast amounts of test data for databases or forms to ensure applications are robust and bug-free, much faster than manual data entry. Robotics. Training robots in virtual environments before deploying them in the physical world. As a developer, you might build rules-based generators. Write scripts to create structured data for specific needs. Utilize ML-based libraries. Learn to use existing AI frameworks and tools that can generate complex data, e.g., image generation libraries, text generation APIs. Evaluate data quality. Your job isn't just to create data, but to ensure it's good enough to train effective AI. You'll assess if the synthetic data accurately reflects the real world's properties. Ethical considerations. Always remember that synthetic data, while powerful, must be used responsibly. Ensure it doesn't introduce new biases or perpetuate existing ones. Synthetic data generation is a growing field, empowering developers to overcome data limitations and build more innovative AI solutions. Benefits. Privacy protection. Generate data that looks real but contains no actual sensitive information. Cost and speed. Much cheaper and faster than collecting real-world data at scale. Bias correction. Deliberately create balanced datasets to reduce bias in AI models. Rare scenarios. Easily simulate rare or dangerous events. Challenges. Realism. Ensuring the synthetic data truly reflects the complexities of the real world can be hard. Quality control. Badly generated synthetic data can lead to poorly performing AI models. Potential for new bias. If the initial seed data for ML generation is biased, the synthetic data might inherit or even amplify that bias. Computational resources. ML-based generation can be resource-intensive. Despite challenges, synthetic data is a powerful tool revolutionizing how developers build and test AI. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.